Good morning, all of you. Welcome to GoOnlineTrainings.com. Yesterday, we discussed about the how to create index and what is an index and why is that index, where is that indexes are useful and where is that indexes are not useful, and all of them we discussed so far. So let me go back and open the learning points whatever we discussed yesterday. Okay, why index? It is used for faster retrieval of the data. That is the primary focus. Why you have to go in for index, and what are the disadvantages of an index, and it slows down the inserts and updates and deletes. That's where indexes are, won't help. What is a table scanning? Reading data from first row to last row sequentially is known as a table scanning. Table scanning is very slow process. Okay. So that we talked about clustered index. Clustered index, it is created when we create a primary key table and data gets sorted in ascending order and index is created. SP underscore help index space table name is used to identify the indexes on the table, and only one clustered index can be created on a given table. Can we have a primary key without having any index? Answer is no. If there is a primary key, you need to have a index. The index can be clustered or index can be non-clustered also. Okay. One more thing. Can we create an index manually? The answer is yes. So this is the syntax we have used yesterday. Create clustered index name on table name. Then you have to provide the column name to create the index. You can also drop the index if you want to. Simply you say drop index and index name on table name, so that you should be able to drop the index. Okay. So types of indexes yesterday, we started with this. So we have clustered index and we have non-clustered index. So only clustered index, then today we're going to discuss about when to use non-clustered index. Okay. Let me quickly go through the PPT also so that you can understand what are the points I had given in the PPT. What is an index and the types of indexes and index maintenance, tuning with workloads and the index tuning wizard. How do you increase the performance of a query with the help of, there is a tool called index tuning wizard. Using that, you can improve the performance of a query. That is also we're going to do. So heap structure, data is stored in a heap structure in the data pages. Heap means, a random order. That means there is no structure in which the data is organized or stored. Okay, that is heap. But indexes are used for the faster retrieval, and indexes will sort the data, will organize the data. That's what we discussed yesterday. Okay, I told you there is a root node and there is an intermediate node and there is a leaf node also. And when you say search for call, what happens is this will point to the Fred are when you need Fred, so which will point to the Fred wherever the Fred is available using the operations. Okay. So yesterday we had taken account ID as an example. Today he is showing name as an example. If you create the name, on that name, if you create a clustered index, and this is how it's going to be shown to you. Okay, this will have a B tree structure, and there you will have the indexes. Uh, so use of indexes. So when you have indexes, primary key, unique key constraints are pretty much good. So when you create a primary key, what happens is indexes are created, and that is clustered index. When you create a unique key, unique constraint or unique key, so which is actually people would say unique key, but you can also say unique constraint or unique key. Okay. So when you create a primary key, what happens is clustered index is created automatically. You please remember this point. Clustered index is automatically. You need not do anything. So when you create a unique key, what happens is non-clustered index is created automatically. Okay. So this is you have to understand this point. when you create a primary key, what happens is clustered index is created automatically. When you create a unique key on your table, what happens is non-clustered index is created automatically on your table. Okay. So we have to discuss about what is a non-clustered index. So I'm going to discuss very soon. So don't worry about it. Okay, but you have to be very clear. When you go in for primary key, only one clustered index is created. And when you create a unique key, automatically non-clustered indexes is created. And indexes are definitely speed up queries and facilitate joins. If you, whenever you join the tables, that is the when also the indexes are used. For example, when you match one with one or two with two or three with three, definitely you need to know where the three is in the opposite table or where the three is in this table also. Okay, so you can use indexes in that time. Okay. Impact of indexes. When you have indexes, what is that, the impact or the disadvantages? Indexes slow down, slow data modifications. I told you, inserts will become very, very slow. Then updates become slow and deletions operations also become slow. Indexes consume space in the hard disk. And indexes can speed data retrieval. This is the last point is actually advantage. First two points are definitely disadvantages when you have any indexes. Okay. Then how SQL Server decides to use indexes, this point I'll cover in the later last this is the last topic. How to use statistics. Okay, this is very important point. People would ask in many interviews. So I will cover this. When indexes don't help, okay, this is also very, very important thing. When the table size is small, or when you have large number of rows need to be written, or statistics are unavailable, in these three cases, indexes don't help. Okay, so let me give you a clear picture. For example, you have a book pages, or the book has only 4 pages. Okay, when you have 4 pages in the book, do you create index on it? Even though you create index, the reader who's going to read the book will not use the index because it has only 3 to 4 pages. Like that, if table size is very, very small, even though there are indexes, the SQL server will not go for index. SQL server will go for table scanning there because you have only 3 to 4 pages, or if you have 10 to 20 days, 10 to 20 rows, even though I have a query which is retrieving the data, instead of going, going to the index page and, again going to the data page will consume time. So when indexes don't help, or the question is when SQL Server does not use index even though index is available. This is the interview question. Okay, then we have to say when the table size is very, very small, then definitely even though indexes are available, SQL Server will not create index, will not use index because it will take much more time going to the index, coming to the data pages. Okay, so this is the answer. Then if you have large number of rows need to be returned, then definitely, indexes are don't help. For example, have you any time, bought a novel? You would have, right? Novel never have any index. Any novel, did you see a novel with the index? You never see any index, any novel with the index. Why? Because novel nobody reads randomly. Novel everybody needs, everybody reads, sequentially or completely. Okay. So when you want to read large data or when you want to read entire data, then indexes are not useful. For example, select star from employee. If I say what index will be used, that is the interview question people would ask. Select star from employee, that means what? You are going to read all the data from the table. So if you are going to read all the data from the table, do you use index? The answer is no. If you want to read entire book, do you use the index and go to the first chapter, second chapter? The answer is no. So if you want to read entire data, definitely we should not use index. Or even though indexes are available, the indexes will not used by the SQL server. Large number of rows, or if you want to read entire data, when definitely all the data table. Also Definitely, indexes don't help or indexes are not used. Select star from employee. There is an interview question. Select star from employee. Which index is used? Is it clustered or non-clustered? The answer is no index. Table scanning is done. Why? Because you are reading all the data. If you want to read all the data, no indexes is needed. Simply you read data a page by page, a row by row. Okay. So the last point would be statistics are unavailable. This point, I'm going to discuss about, this point later because this is beautiful point you have to understand. Okay. So you have to be very clear. Even though indexes are available, when does SQL Server will not use? The first point is table size is small, or when you want to read large number of rows, or you want to read entire data from a table, then definitely indexes are not useful. Or when statistics are unavailable, then you have to go in for table scanning instead of indexes. Then types of indexes, one is clustered index, the other one is non-clustered index. So clustered index, data is maintained in physical order, then slow inserts, then faster queries, resolving the index, indexes resolving the index produces data. So that means what? When you create index, what happens is index will create a root pages and index will create intermediate pages and the data is ordered like A, B, C, D or 1, 2, 3, 4 like that. Then every row will have an number. So this is page number one, row number one. This is page number one, row number two. Page number two, row number one like that. The data is organized for each and every data. You will have the index numbers or the proper indexes. So if you want to get Adam is available in page number one and row number one. If you want to get page number four, row number two, like that. For each and everything, you will have an index. So tomorrow, using that, you should be able to retrieve the data easily. So when to use for clustered index? So clustered index are very, very good if you want to return ranges and if you want to get sequential access. When you want to have used by group by order by clauses, okay? And when you want to have, searching operations, OLTP single lookup operations, then definitely you can go in for the clustered index. So clustered indexes are always used when you want to, get range of values. What do you mean by range of values? Select star from employee where employee ID greater than 5 or less than 5. So if I say greater than 5, there is a big range. Greater than 5 means I have 10,000 employees. So 5,000, 6 to 10,000 employees I need to get. This is a big range. Or, select star from employee where employee ID between 1,000 to 2,000. There is a range. 1,000 to 2,000, less than, greater than. All these are best examples for, returning ranges. So when you want to get like ranges, then always go in for the clustered indexes. Bad choice, frequent row modifications, and if you have wide key in the sense, the key column itself is very, very wide. So always key column must be, very short in the length. But if you have, very big size, okay, then that's where this will be very, very slow. Okay. So there is a interview question. When does we have to go in for clustered index? Then you have to say when you want to retrieve a range of values. For example, when you want to retrieve a query like this. So I'm talking about select star where employee ID greater than or equals to 1,000. So after 1,000, whatever values you have, you need to get it. So if you have these kind of stuff greater than or less than or between all of them, okay. If you want to get range of values, then definitely you have to go in for clustered index only. Now let me go to our table and let us understand now what is a non-clustered index when we have to go in for non-clustered index. So let me go back to our table. What is our table? So our table is this. Okay. This is sorted. I have a primary key. I have a column in this. Now I am asking. the another query. What is the query I'm going to ask now is like this. From employee, where if I ask you where account ID equals to 2, definitely I can use the index. Wherever the account ID equals to 2, I should be able to get the data. So because I have an index, index is used and set to the data. But when I say where city equals to, now I have city Bangalore, I have city Hyderabad, I have city Chennai. Where city equals to Chennai or Hyderabad, how do I get the data quickly? Now, since I have very small row, this query will give you data very quickly. But the tomorrow you may ask question, I don't know where the city. City may be in the first page, the Chennai may be in the first page or last page or the middle page. You don't know where this data would be. Okay. Now you have account ID column here, and that time SQL Server will use clustered index or index which is there on that column. But city column does not have any index. City column does not have an index. Now you have to go in for one more index because one index is not sufficient, because when you have a index on the employee id, only when you have employee id equals to equals to 2 equals to 3 less than that greater than that, only on that if you want to search that index is useful. But now I am using a separate column itself where city equals to Chennai. I don't have any clue where my Chennai city is. So if you see yesterday's example also, I have created on this one. So 1 to 100 are available in first page, 102, 101 to 200 are available in second page, like that. The actual data is sorted, that depends upon the other employee ID here. But today I'm talking about Chennai guys. So Chennai guys are available in page number one. Chennai guy is available in page number two, or Chennai guy may be available in page number three, like that. So the data is not yet sorted or organized on the basis of Chennai or basis of city. Okay, so data is organized in the basis of the account number or the employee ID. Here the data gets sorted, but again you don't have any clue where the Chennai city students are. They may be in first page, they may be in second page, they may be in third page, they may be in fourth page, or they may be in thousand page also. I don't have any clue. If I have this kind of query, definitely the existing index will not help. What is the index we have on this table? We have sp underscore help index. So employee, what is the index we have? Let us see. We have a clustered index only there. The clustered index on EMP ID, it is there, but now I have to go in for one more index. Why? Because I am searching on city column. So this will give you one more point. That means one index is not sufficient for you to retrieve all the data. Okay. So if you have city column, you need to create one more index on the city column. Or tomorrow, if you have gender column where gender equals to M, then definitely you have to go in for one more index on the gender column. Now I need only male people or I need only female people. Now you do not have any index on the gender column also. That means the employee ID has an index, but that index is I'm not searching now. I am using different columns. Okay. So it is very important that whatever be the column here you have used in the where clause, on that column the indexes need to be created. Okay. So now gender column need to have indexes when you're searching like this. When you're searching for city, then you have to go in for city index on the city column. But the question is, you can have only one clustered index. So definitely you cannot have one more clustered index on this gender column or on city column. So the next choice would be for you is you have to go in for the non-clustered index. Okay. So let us create a non-clustered index on the city column. Okay. Now because I need to get Chennai data. So how do you create same syntax here? This is how you create a clustered index. Now let me create a non-clustered index. Okay, empty table. Instead of cluster, you remove cluster. Create index I 1 to 4. Okay, on employee. In which column you would like to create? You would like to create on the city column. This is the what. If you don't mention either clustered or non-clustered by default, which is non-clustered. For clustered, you need to mention either clustered, but now I'm creating create index I124 on employee where on city column. So this is going to create a non-clustered index on this column. If you don't mention anything by default, which is non-clustered index. F5. Okay. Let me understand what are the indexes I have. I did not mention whether clustered or non-clustered. If you don't mention which is by default non-clustered. So let me just go there and understand. So I124 is non-clustered index on created on a city call. Okay, so this is how you have to create non-clustered index. Now I have a column on the non-clustered index. Now when I have created a non-clustered index on this city column, how does the index pages are created and how is the structure? So let us understand like this. Now this is the clustered index already we have. And a clustered index root node will have index page. Clustered index, intermediate page will have index pages. And a clustered indexes, a leaf node will have data. This is an interview question. You have to be very clear on it. Clustered index leaf node contains what? Clustered index leaf node contains data pages. Okay. Now, when you have a clustered index and a clustered index has the data organized like this, now we have created what is known as a another index called, index on city column. Now, the index created on the city. So let me show you the non-clustered index now. So this is actually clustered index architecture I shown you as. This is the clustered index. Clustered index always would store the data with the index itself. Clustered index. This is. Now I'm going to show you non-clustered index diagram. Clustered index. So I have created on the city column. Now first what happens is non-clustered index also will have a root node. So let me take the diagram like this. My root node in the non-clustered index. So this is extra index which is going to be created. Now in this, so like this. Now it will say, I have what are the cities I have? Let me simply go here and understand what are the cities we have. Now we have Hyderabad, Bangalore, Chennai. Three cities I have. Now it will say, first it will go to, Bangalore. Bangalore is available in, it's available in, say, 1 comma 2 like that. Okay, or page number 1 like this. And Chennai. Chennai is available in, let us say, page number 2. Okay. Then you may have Hyderabad. Hyderabad is maybe available page number 3, comma 4. Like that, it may give you some data. Okay. Now after that, you will have again sub nodes. So this will have again sub nodes. So this is number 1, 2, 3 like this. Then let me delete this. I need some space here. So I'm just deleting this. So what I'm going to do is, this is the page number 1. Okay, this is the page number 2. This is the page number 3 like this. So you will have numbers. Okay, page number 1. This is page number 2. And this is page number 3. Okay, like that you will have page numbers. Now here you should be able to get all the data for the Bangalore or all the data for for this one. So what happens is here you may have Bangalore data. So let me just show you. what is known as a page number, row number is stored here. Okay, page number, and let us understand what is the page number and what is the row number. Okay, now for example, I have data. Now for example, I'm talking about Chennai data. Chennai data is available in page number one. This is page number one. See, remember, this is page number one, and row, this is row one, row two. Okay, so it will say, if I need Chennai data, I need to go to some other page, or Hyderabad data. Where is Hyderabad data? Bangalore data, like that. If need Hyderabad data, this data, that data depends upon the this number, it will go. If I Chennai data come here. So here you will also page number, and plus you may have row number. Data I am looking for. So Chennai data is available in page number one. It will store the page number one plus what is the row number? The row number 1, 2. This is Chennai. 3J Chennai. So the row number is 2. Okay, like that. So I need Hyderabad data. Bangalore data. Bangalore data may be in page number one. It comes here. So Bangalore data, wherever you have Bangalore data here, that will be stored. Okay, Bangalore, the entries are not here, but if I have entries here, then definitely, for example, I have, this is the, say John. Here, John is from Bangalore. Okay, now let me put Ravi from Chennai. Okay, then I have Lalita. Like that, I have data is stored. Now, what happens is now for Bangalore. Who's Bangalore? Do you have any interest for Bangalore as of now? Yeah, yes. So here it will say page number two. Page number two. It will store here. Page number two plus what is the row number for Bangalore? One. You can have a pointers like this. Okay. If you need Chennai people, and page number two also I have Chennai. So page number two plus what is the room number? Uh, Row number is 2 again, like that. If somebody asks, I need select star from employee where city equals to Chennai or city equals to Hyderabad, then when I say Chennai, the SQL server will come first here and it will pick up Chennai. It will pick up Chennai. So what happens is now you will get Chennai here, and Chennai data will be taken care first. Okay. Once that is there, then from Chennai, which will come, for this, and which will pick up something else. So it will pick up Chennai and it will come to two. It will come here and it will pick up one. It will go to page number one, row number two. It will go to page number two, row number two, like that, which is going to pick up all the data from here. So this will have a pointer like this. Okay, I don't have pointers. Address is stored here or page number one, row number two, like this, which will take pointer and which will store. So this is the pointer. So like that, you should be able to understand and create all your the pointer. Like that, the non-clustered index will not have any kind of data now. The existing data will get pointed by using non-clustered index. But non-clustered index is a only pure index pages which are created automatically, but which will point to the clustered index leaf node for the data. Okay, only address is stored for each and every city. That's it. So which will go for Bangalore. Bangalore is available in the page number one. Page number one will contains only for the Bangalore data. Page number two always maintains the Chennai data. Page number three always maintains the you know Bangalore data or Hyderabad, like that. You will have a page number plus the row number which are maintained as a address or as a pointer. So you have to go to the clustered index leaf node to get the data, because clustered index leaf node maintains the data only. So non-clustered index does not sort the data. You have to be very clear. You have to be very clear on it. Only creates a index which will not sort. which will not do anything. Only clustered index sorts the data, which creates a data index pages, but non-clustered index does not sort the data, which only create a index pages extra. That we have to understand. Okay, if you take tomorrow clustered index, same kind of index pages are created, but those index pages will point to the leaf node of clustered index. So this is how the clustered index, non-clustered indexes are organized in your data pages. Even though there is a leaf node, it will maintain leaf node. Even though there is a leaf node, if you have number of pages, leaf node will be there. Then leaf node will contain again point. You can have leaf node also if you want to. If you have less data, leaf node will not be there. Okay, if you have used data, then root node, intermediate node, then leaf nodes will be there. Leaf node again will point to like this. But if you understand the structure, but you may have or you may not have. But many cases, indexes are created when you have used data. So definitely you will have a root node, intermediate node, and the leaf node. But leaf node will point to the clustered index leaf node to get the data. Clear? But if you understand the focus non-plus index, that's it. So which may have, which may not have, depends upon the data. But normally most of the cases which will have a root node, intermediate node, leaf node will point to clustered index leaf nodes. Please. Okay, any question? Okay, so this is how you have to you need to understand non-clustered indexes. Non-clustered indexes are very much useful when you want to retrieve the data. But you may ask a question, but tomorrow if I need where the gender equals to male, where gender equals to female, so I would like to retrieve the data. Again, the city index which is created on the city column will not be useful. So tomorrow you have to create one more index on the gender column, that is also non-clustered index. You can have triple nine non-clustered indexes per table. So how many non-clustered index you can have per table? As of now, 999 plus one clustered index. So 1000 indexes per table you can have nowadays. Okay, but in the previous versions, there was a restriction. You can have 255 non-clustered, one clustered like that. But now in SQL Server 2008 R2, you can have one clustered index per table, triple nine non-clustered indexes per table. Non-clustered index is created when you create a unique key. Apart from that, also manually you can create a non-clustered index. Okay, you can have many unique keys per table. Each unique key will have a separate non-clustered index. So you have to be very clear on it. Okay, that's what the index is. Now, you need to understand what is a fragmentation in indexes. People would ask in interviews. What do you mean by fragment? So what happens is normally, now let me explain. I have a data here. I have some data. I have the data got stored. Okay, so let me put some data here. Now I have some A, this. I have some 2, B, say from 20,000 rupees. I have some 3,000 rupees like that. So what happens when you enter the data is organized like this. What happens is here. So the second row is I don't need, I will delete the row here. Our third row is I don't need, I may delete the rows here. So when you delete the rows here, what happens is SQL Server will not organize anything. SQL Server leave as it is, the data. So what happens is you will have empty spaces in between. The empty spaces is known as, which got created in between. So this is not, okay. This portion is known as a fragment. So let us understand what is a fragment. Fragment means a empty portion. Now, if you have fragments in the pages, what happens is definitely your data, you may have 100 rows, but 100 rows are not available in a single page. 100 rows are split into 100 rooms. You think that you have a big godown, but there are many items you put it, but you have to remove all the many items from the all rooms. So what happens is, so one room has 10 items, another room has 20 items, again one more room has 5 items like that. So we have only few items left, but to get the few items, you need to visit 100 rooms. Why? Because you did not reorganize the data or reorganize the items. Because once you delete, you have to bring all the items from the second room and keep it in the first room itself because you have space in the first room. Okay, so you have created a fragments. Why fragments will be created? Fragments will be created when you do insert, delete, updates, insert, deletes, updates. The fragments are created. What is a fragment? Fragment in the sense you have to empty space. SQL Server will not automatically create or remove the space which will be there in the data in the pages as it is. But if you have a page, the page may have only 2 to 3 rows, then that gets filled, and the remaining data will be in the second page like that. So you will have very small data, but small data is will have in a different across pages, and those number of pages are huge. When you have huge number of fragmentation, then to get the data, I need to visit many number of pages. Definitely, the slow the even though there is an index, the process would be very slow. Okay, you have to defragment the indexes, or you have to defragment the the tables or the indexes to remove the the spaces in between which are created by insert, update, deletes. When you have bulk operations, definitely fragments are deleted. When you do bulk delete, bulk insert, bulk update, you will have these kind of issues. Okay, so if you have fragment, even though there is a index definitely will not going to help. We have to be very clear on it. So you have to do what is known as a defragmentation. Fragment means what? A space in between. Defragment means you need to remove the space which are available. So what you do, you go to 100 rooms and get all the items. Reorganize it from room number one onwards. One, two, three, four, like that. Okay. So what happens is the empty space will be left it later. Then all the data will come front, will come to the first pages. Okay, so the in between gap will be removed when you perform defragment operation. So the question is, how do you perform defragment operations? So I told you defragment operations can be done using index defrag, and this one more command called, this is the index you can use. So index reorganize. This process physically reorganizes the data, and this process drops the existing index and recreates the index. If you want to defragment, you have two choices. These two choices you have to understand. One is this one, you need to understand. You have to go in for this. So index, this process drops the existing index and recreate the index. When you do this, what happens is the data is again physically sorted, stored, and the defragmentation is going to it will do that. On which table? On employee table. Table, I have to perform the defragmentation. That is done. Or you can reorganize the index. This process physically reorganize the leaf nodes of the index. This is also you can perform if you want to, defragment the index. Okay. Or you have one more command called dbcc index defrag. This is also you can use, for the test database, which is the table you're going to use. This table, you can use number of tables here. So using that, you should be able to, use this. Pages moved, pages removed, all of them, but the pages scanned. You don't have much data, so you cannot understand many things here. So test is the database. This is the table. You can also use a dbcc command. dbcc commands are, mostly used by the database administrators, not by the developers. Okay, database consistent commands, consistency commands, dbcc commands. dbcc index defrag is the command you can use to defragment. Okay. So further reading you can do on this. So when to use what, but actually all these commands will be maintained by the DBAs. Okay. So this is what is a clustered index and non-clustered index. You can have only one clustered index per table, and you can have many non-clustered indexes per table. So let us understand. Told you about pointer arrays. If the clustered index has a on the table, then the pointer would be, if the table has a clustered index, point is the clustered key itself. Okay, so every row will have a key. Okay, the key will be given to the non-clustered. So when you have Bangalore data, it will say you go to row number 1234, row number 1234, or that is a clustered key where Bangalore data will be available. If the table is not clustered, the pointer is row ID, and that point to directly to the location of the data. Row ID plus it will also use what is known as a page number. Okay, to get the data. Clustered index, when is that you have to use large number of distinct values. If you want to get, this is the good value. Then if you want to store exact matches, then you can use this. Then when you use joins, this is good. And low number of rows returned, then good. And when you want to retrieve a range of values, this is very, very bad. Okay, low cardinality in the sense you want to get very less number of cardinality rows. So definitely this is not going to help you. Okay, so the thing is that clustered index only one per table, and non-clustered index you can have multiple per table. Retrieve ranges or retrieve few rows with query. If you want to get ranges of data, you go for clustered. If you want to retrieve only few rows or exact matches, you can go in for the non-clustered. Access single row data, create covering index with a subset of the data. I'm going to talk about covering index also, which is very, very important for us to discuss. Okay, subject to fragmentation. Fragmentation, I told you. What is a fragmentation? When you delete operation, when you perform bulk deletes and everything over a period, the fragmentations are created. So you will have less data, but the data is organized in many pages. So you have to remove those gaps. To remove those gaps, we need to do the defragmentation. Okay. Maintaining indexes, fragmentation we have to do it, and checking indexes, rebuilding indexes, and we have to also use statistics. Okay, so fragmentation I discussed about. Checking indexes I told you, SP underscore help index to checking indexes. Rebuild indexes also I gave you some command to use rebuild index, reorganize indexes, and disable indexes. And statistics I am going to tell you tomorrow. Okay, index fragmentation results from filling pages in the clustered index, and slow down queries, necessitating extend switches, repaired for, rebuilding the index. Fill factor and pad index can, trade space for speed. Okay, this is also very, very important. What is a fill factor? That is also I'm going to tell you tomorrow. I'm going to tell you what is fill factor, what is, the statistics, and what is covered index. All of them we're going to have. These are very, very simple topics and important topics. Okay, checking indexes, these are the commands you can use. dbcc check db, then dbcc check table, dbcc show counting. All these are, to checking the indexes, but these commands are actually used by dbas a lot. Okay, how the pages are occupied, how the data is there, how, how many pages are there, how much data is there. All of them you can easily understand by using these commands, apart from sp help index. Okay, you can also google it, you can get the syntax, and please have a look at these commands. Okay, and tomorrow when we come, we can do much more on this. Rebuilding indexes, you can drop create index, or you can use dbcc reindex, or you can use dbcc index defrag. Okay, so how do you do, rebuilding indexes are the questions asked in interviews, but not as a developer, but as a dba you have to get all this, work done. Okay, so tomorrow We'll talk about, the remaining leftovers. What are the leftovers we have? Maintenance statistics and the wizards. Index tuning wizard also we have to, tomorrow we're going to discuss about it. Okay. So what all still we have to cover in this topic? So need to be covered. So tomorrow we'll understand statistics. Then we are going to understand covering index. Okay. What is the covering index? And we need to understand what is else, and index tuning wizard. Okay. We have a tool called index tuning wizard. That wizard we need to understand. Okay. Tune the query using this wizard. Okay. By using workload. Index tuning wizard we need to understand. Anything else? So if you have something tomorrow, discuss. So indexes are, widely used only in the data retrieval process. But if you don't have, this one, don't go in for the indexes. Okay. I told you one query. I told you one scenario. What is that? The scenario is, the question is like this. When does, as you're running SSIS package, then SSIS package, taking lots of time to insert the data. How do you improve the performance of the SSIS package? That is the query. SSIS package, taking lots of time to insert the data in a table. Insert the data in a table. Do you improve the performance of the package? So tell me, how do you improve? Okay. So you always either disable indexes, you disable indexes. Okay. And you can also disable, check constraint, because validations and all should not be done. Okay. Then disable table. Okay. Disable indexes, disable check constraint, disable triggers. But if you disable all of them, validations are not done. But if you think that you need to validate the data, then don't do that. But if you think that I don't want to validate the data, then definitely you have to disable check constraint, disable triggers, all of them. Then disable, statistics. Tomorrow I'll show you how to disable statistics. Okay. All of them you have to do it. So then only you can improve a SSIS package performance. Okay. All these are very, very important for you to understand. Okay. So tomorrow we'll discuss. Do you have any questions? Any questions? Okay. So clustered index always used for when you want to get range of values. When you want to get exact match in the sense that start from employee table, where, city, say Hyderabad. Now I'm comparing with equals operator. When you have equals to operator, equals means exact operator. Okay. When you want to retrieve data like this, then always go in for the non-clustered indexes. Okay. When you have, greater than, then less than, then that's where you have to go in for the, clustered index. When you have equals to operators, then always you have to go in for the non-clustered index. So non-clustered indexes are used when you want to retrieve the data, exact matches. Go for the clustered indexes when you want to retrieve data in ranges. Okay. So you have to be very clear on it. So clustered index only one, non-clustered indexes are many. Any questions, you can just ping me or call me or you can just mail. Okay, I'll upload this. So tomorrow we'll discuss. Okay, thanks. Anything else?